Okay, so this is our last section on radicals. It is radicals day 4. We're rationalizing our denominator. So our objectives are to understand, multiplying an integer and a radical. And our second objective is to rationalize radical denominators. Make sure you write both of these down. The sub is going to be checking your notes to make sure that you have all of these examples written down. There's not that many. These are your only examples you get. So please write them down and write all the steps down. Okay, so remember our perfect squares list? Make sure you have this at the top of your page or written down somewhere. You should have it written down. There's also a picture on your phone that you should have. But yeah, you should have this. You should also get out your factor chart. So get out your factor chart. Okay, so we're going to practice just multiplying an integer and a radical. So first, we're going to multiply two integers. So 4 times 4, that's 24. Okay, square root of 4 times square root of 6. Well, if they're both in the radical, you can multiply them. So this is the square root of 24, which we then can simplify. So we would write this as 2 square roots of 6. But I'm just wanting you to see that what we do is we multiply if they're both inside. And then we have 4 times the square root of 6. Well, we have 1 under a radical, 1 without a radical, which means that you can't combine them. So what we write is just 4 square roots of 6, and that's it. Okay, so it's going to be a little bit easier. These are the steps we're going to use when we're rationalizing our denominator. So when I say rationalize a denominator, it means that we cannot have a radical down here in the bottom of our fraction. Okay, so in a fraction, if we're dividing something, we can't have a radical. It's really not allowed. So what we do is it's called rationalizing the denominator. We're putting that radical to the top of our fraction. So what we do is to get rid of a radical in the denominator, you multiply both the numerator, so top of your fraction, and the bottom of your fraction by the radical, and then we simplify. So right here we have the square root, we have 1 over square root 2. So what we do is we multiplied right here by square root 2. So when you multiply in a fraction, you multiply across. Okay, so 1 times square root 2, that's 1 square root of 2. Square root 2 times square root 2, that's square root 4, which we then simplify to 2. And the top, that square root 2 stays there. So this is our final answer, okay? If you need to, pause the video, write this down. Our first example now. So we have 1 over square root of 11. Well, we don't want that square root of 11 in our fraction. So what we're going to do is we're going to times the top by square root of 11 and the bottom by square root of 11. When you multiply fractions, you multiply straight across. So on the top, we have 1 square root of 11. On the bottom, we have the square root of 121. So the top, that's just the square root of 11. In the bottom, square root of 121, that's a perfect square. That turns just into 11. Okay. Next example. So we have 3 over the square root of 5. So we don't want that square root of 5 in our denominator. So let's multiply to get rid of it. So multiply both the top and the bottom by square root 5. Okay, so on the top we have 3 square roots of 5. On the bottom we have the square root of 25. Okay, let's simplify some stuff. So on the top, 3 square roots of 5 cannot be simplified further. On the bottom, square root of 25 is just 5. If we look our fraction, we can't reduce it. So we are done. Okay, we got 18 over square root of 6. Well, we don't want that square root of 6 in our denominator. So what we do is, remember, multiply by square root of 6, both top and bottom. So in the top, we have 18 square root of 6. In the bottom, we have square root of 36. So we have 18 square root of 6 over 6. Our square root of 36, that's a perfect square. We can pull that out and have just 6. No radical anymore. We lost our radical. Remember, when you take the square root of something, we lose the radical. Now, if we look, this fraction, we can reduce it. 18 over 6. So that reduces down to 3 square roots of 6. Okay? So, reduce your fractions. So our next one, if you look at this, don't always rationalize first. See if you can simplify. So simplify first. Square root of 49 is perfect. Okay, it's a perfect square. So this turns into 28 over 7. You didn't even have to rationalize. 28 divided by 7, that's 4. So don't overthink some of these problems. Look and see if something that's a perfect square first. Okay. Same thing right here. We got a perfect square in the bottom. Square root of 9 is a perfect square. So we have 1 over 4 times 3. Square root of 9 is 3. So you can just change that to a 3. So now on the bottom, we have 1 over 12. Okay. On the bottom, let's look first, see if we can reduce anything. We can't reduce any of our fractions. So sometimes it's good to see if this divides at all. They don't. Okay, now let's look at our square root 2. Nope, that's not a perfect square. So we have to rationalize. So let's take square root of 2 on the top and the bottom. That's a little bit hard to read. Okay, so in the top we have 10 square roots of 2. In the bottom we have 3. And then we have to multiply if they're both in a radical. So we have 3 square roots of 4. So the same type of thing that was going on up on the top. So we have 10 square roots of 2 all over 3 times 2, because square root of 4 is 2. Okay, that's what we did right there. So now we have 10 square roots of 2 over 6. Okay. Reduce. So 10 over 6, that reduces down to 5 over 3. So you have 5 square roots of 2 over 3. And that is your final answer. Okay, that was all of our problems. So the assignment is our worksheet. So pause the video if you need to. Okay, so our assignment is the worksheet. The sub has a key, so you guys can check it. So make sure you're just looking through. Also, another rule, if we have something that looks like this, we can break it up the same way we broke up our multiplying. So some of that might go in that problem in the worksheet. So you might need to use this rule. Don't forget our other rule. So if we have square root of a times b, that's the square root of a times the square root of b. Look for your perfect squares. So look for your perfect squares. Okay.